Hi, thank you very much for the invitation and for the introduction. I'd be very happy to talk a little bit about the research I've been doing on using visual information in conversations with social robots. So, this research is really rooted in the premise that robots need to be social. We're talking about applications such as healthcare, elder care, education, applications that we've been doing research in for at least 20 years now. And we know from that research that robots really can have a benefit to people in these applications. But why are they not everywhere yet? Well, one of the challenges is to make these robots truly autonomous so that they can really work in the wild. And one of the main challenges to make robots autonomous is conversations. Because in these types of interactions, we're talking about a specific type of conversation. We're talking about social conversations, where we're not just trying to accomplish one task, where the robot is not just our assistant, but really we want a good chat with the robot. We want it to be a social partner that we can maybe even develop a relationship with. And we're talking about embodied conversations at the same time. The robot has a physical body, it's not just a disembodied chatbot or voice assistant, and it's also taking place in a real physical environment. Now, you might think that today this is actually quite easy. We just take the robot, connect it to a multimodal large language model, such as GPT-4o or any other LLM, and problem solved, right? Well, no, not really. Why is that? Well, that is because of this specific type of conversation, because of these social embodied conversations. And that means that we need to use all the modalities that happen in the conversations, including visual information, and we need to use them in multiple ways. And to explain that, I will show that to you using the model of conversation described by the psycholinguist Herbert Clark. And Clark, he described that conversation actually happens on two tracks. On one hand, we're trying to achieve the main communicative goals, we're exchanging information, trying to accomplish some task. And in that, of course, visual information plays a role. Um, but also in the second track, when we're trying to send and interpret feedback on how the conversation is going. Do you still understand me? Are you still interested in what I'm saying? And on that first track, we're using visual information to make references to things that we can see. And robots need to be able to make and understand such references. And in the beginning of my PhD, I did research on how we can use multimodal large language models to make such references. But on the other hand, we also need that sending and interpreting of feedback. We need to detect feedback, and one of the ways that feedback is expressed is through visual information, such as facial expressions. So we can see whether the robot can, for example, detect from the facial expressions whether the robot has made a mistake. On the other hand, we also need to adapt to that feedback. It's not just enough to know that robot made a mistake, we also need to know what it can do better. And I looked at how we can use large language models to analyze a conversation and know what would be the more enjoyable way to move the conversation forward. But can we bring all of these skills together? Can we build a holistic system that drives a long social conversation and that can continually adapt to visual context? And can we actually study whether using that visual context improves the conversations? So we embarked on a quest to build such a system, and we did that using a vision language model. This was Gemma 3. That's a small vision language model that we can run locally. And that's important because, of course, when we're using visual context in these types of applications, we want to treat them securely with respect to the user's privacy. At the same time, we also want to eliminate any network-based errors or delays. So using a local vision language model is really important for this. And we use the model for different parts in generating the robot's response. On one hand, we use it to analyze whether the user's turn is finished and it's the robot's time to speak. Secondly, we of course use it to analyze the images. We take 5 images every turn with about 3 seconds in between, and we let the VLM analyze whether there's anything interesting in these images that the robot should mention or adapt the conversation to somehow. We also let the VLM reflect over the course of the conversation and the expected progression of the conversation. And we let it decide whether it's time to move on to the next stage of the conversation and also instruct itself on what is important to accomplish in the next utterance. And we use that instruction to then let the VLM again generate the last response. Now, can we then measure whether this is a good conversation and to know which conversation is better if we're trying to compare two systems? Well, on one hand, we use different methods. Just as in other studies, many studies used many different methods. We looked at which robot that users actually prefer. We also let people fill in a questionnaire and we do an interview with them in order to get a feeling for their perception of the robot and of the conversation. And finally, we let external people annotate the conversations and indicate whether the robot has made certain mistakes or what's happening in the conversation. But what's also important is to make sure that we have comparable conversation. Instead of just letting people talk with the robots connected to an LLM, we try to have semi-structured conversations, because otherwise, how well people enjoy the conversation will really depend on what they started talking about. So we used a set of fixed questions, like the one that you can see here, in which the user and the robot were completely free to talk about anything they wanted relating to that question. They could talk about it for as long as they wanted, and the initiative lied with both the user and the robot on whether it's time to move on to the next question. But using this, we could actually have some comparable structure of the conversations, and at the same time, we could leverage the flexibility that large language models afford. So we took this setup and brought that to the city library, where we recruited 20 people to come talk with our robot, with our two robots actually, because every participant talked with one robot that could see and one that couldn't. And they went through two different question sets, with each of the robots. And what did the results actually show? Well, on one hand, we showed that the VLM is actually very accurate. References of the VLM regarding things in the environment, the clothing of the person or their accessories, or even more dynamic things such as gestures and facial expressions. According to our annotators, the responses of the vision language model actually reached very high accuracy when it comes to these visual references. But what did the participants think? Well, they actually didn't have a clear preference for one of the two systems. Some people had a clear preference for the robot that could see, but others had a clear preference for the robot that could not see, while others didn't have a strong preference. And if we then looked at the interviews, then we saw that some people said that the visual information actually led to a more personalized, interesting conversation, and really the feeling that the robot was in the room with them, which is what we try to achieve, of course. At the same time, some people said they found it creepy when the robot mentioned something that they could see, that they felt watched, or that the robot's comments were not really fitting in the conversation. So, what was the thing that drove some people to prefer one of the two robots then? Well, what we did see in the questionnaires is that the user's preference is strongly correlated with how well coordinated they found the robot to be. They clearly found some conversations to be much more coordinated than others. So what actually led to a better coordinated conversation? Well, there we saw that the robot repeatedly made some types of mistakes. Some were due to speech recognition failures. Sometimes it was because the robot repeated something it had already said. But what we also saw is that sometimes the robot and the user were not well aligned on, for example, what question to talk about or whose turn it is to move the conversation forward. And also sometimes the responses of the robot were really not focused. The robot would at the same time mention something that it saw, respond to what the user just said, and already start talking about the next question, which is just too much. And it was actually these two last mistakes that significantly correlated with how well coordinated people found the conversation to be. And this leads us to show that language models, despite the fact that they are very good at analyzing languages and also images, they lack certain conversational social skills. Skills like pursuing multiple objectives at the same time in a conversation, or planning ahead multiple turns. You don't just say everything that is on your mind in the next response, but you actually wait throughout the conversation. Also, we need to switch initiative between turns. It's not always my turn to ask the questions or your turn to decide what we're talking about. And also knowing when and how to use visual context is a very delicate and nuanced thing. And these social skills are things that come quite naturally to us as people, but they are not yet there in vision language models because they are not built for social embodied conversations. So how can we solve that? Well, there's a few ideas. On one hand, I think there's improvements to be made on the input side, for example, with more efficient vision processing and improved speech recognition, but also skills such as analyzing these subtle nonverbal signals within the context of a conversation. But also on the output side, right now we are very constrained with the turn-by-turn nature of the conversations, but sometimes something is just too urgent to wait for the end of the turn, or sometimes it's better to leave some silence and not speak immediately when the other has finished speaking. I think also we can make improvements on the system side that transforms that input into that output. And maybe we can take some inspiration from human cognition. Uh, in our mind, we are constantly having multiple processes run at the same time in parallel, and we are predicting how the conversation will go and adapt to the progress of that conversation. So maybe we can design a system that replicates more these characteristics of human cognition. And at the same time, we need to train our systems and evaluate them on better data. We need to evaluate them on real social embodied conversations and train them on such systems. Maybe we can do interactive learning setups and actually evaluate them on real interactions. And it leads us to the question that is still not answered, which is how to measure conversations. So in general, I hope that I've convinced you that using visual information is an important challenge in achieving autonomous multimodal social robots, that we're not really yet there. It's a challenging problem, but that with the current technical progress that we have and some good interdisciplinary collaborations, we can make significant progress in order to make actual better multimodal social robots that can help people. If you want to know more, have a look on my website and the different papers that I mentioned in this presentation, and I'd of course be happy to answer any of your questions.
Thank you very much, Ruben. That was a fascinating presentation and a great example of how multimodal AI can enhance social interaction in robotics. As a matter of fact, personally, one of the papers which you were discussing throughout the presentation, I was very interested about, and I was reading a couple of papers related to this. So personally, I do have a few questions, but we have our audience lining up for with their questions. So let me go through the audience questions first, and then we will get back to me. So, are you here, Ruben? Hello.
Absolutely. Yes. Hi.
Hello. So one of the audience, one of the participants had a question regarding conversational pacing, and the question was, what strategies can prevent a robot from being unfocused by trying to say too much in a single turn?
What strategies could prevent the robot from being
From
unfocused?
being unfocused, yeah.
Yeah, well, I think there the fact that a robot should have a plan for the conversation, I think, is one of the key strategies that I think lies some promise in. Because right now, LLM-based systems, they don't look further than the next turn. While in reality, we keep things on our mind, right? We have memory throughout the conversation, and we don't just mention everything that we're thinking of right in the next response. That's not a very good conversational strategy. So I think. Building a system that can make a plan and that can prioritize what is important to say right now and what is not, would be a very good step in that direction.
And you think this would not be based upon LLMs?
Yes, of course, that will be based on LLMs, but just using one single LLM out of the box, as we often do right now, right? Of course, it's
Mhm.
very, very cool technology, so we want to do with it what we can. That's not enough. We need to build smarter systems based on LLMs that maybe use different LLMs at the same time, but really go back a little bit to the way dialogue systems were before LLMs, with these very intricately crafted and engineered systems, but with
Yes.
LLMs as the building blocks.
Yeah. Also, we have a question from Paula, one of our viewers for today. And her question is, what are your thoughts on using social signals from voice? Would adding that modality improve the interactions in addition to the other modalities?
Yeah, absolutely. I think this is one of the big missing elements. So, of course, in my PhD, I had to focus on one thing, which was the visual element. But yeah, there are so many aspects of prosody. But I think there is lots of interesting work on analyzing prosody to get an image of a cognitive state of a speaker, for example. Um, but this hasn't really been combined yet with the power of generative AI, of large language models. We have multimodal language models that can take audio in, but they are still quite blind to prosody. And I think that's one of the most interesting things that we can move towards right now. But it's very difficult. Yeah.
And we have also another question. So, having a comment first and then a question. So he's saying very interesting work, Ruben. And then he was asking if you have any insights on what field or use cases or application visual context would be important for the robot.
Ah, yeah, lots. I mentioned three applications in the beginning, the education, the healthcare, the elder care, but I think it comes down to the question as well, which conversations would you rather have in person? Um, because, yeah, we can think about why don't we just use a voice assistant? Why don't we just use a conversational agent? But there it comes down to when is it important that we get all of these modalities, that we can perceive the other person in all of the modalities, but also that we can express ourselves in all of the modalities that's present. And vision always plays a big role in that. So I think these emotionally laden, more personalized conversations, those are the places where visual context is very important. Unless, of course, you're talking about a task where the visual environment is very important as well. That's a different element of the same question.
Which tasks do you think like the visual and but also including of course a robot. So which tasks do you think would be like pivotal in such an area which
Yeah,
require a visual environment?
when I'm thinking about really concrete tasks, then we're talking more about collaboration or where there's a physical object that you're talking about or that you have to use in that task. So that's, of course, where that would be more important to see what's around us in the environment. But I think it plays a role in more social interactions as well.
The questions are keep on coming. I don't think I'll have enough time for my questions, so, but they're being covered by our audience, more than question of mine. So we have Roger as well, and he's saying, "Nice talk, Ruben. And did you try any prompting strategies? For example, exploiting one step at a time?"
Yeah, so in that, I showed one slide with the different components of the system. So there we were kind of building the response one step at a time with the different elements, seeing whether the turn is finished, analyzing the vision, reflecting over the course of the conversation, and then generating the response. And in each of those calls, we used different prompting strategies. So that included some examples that we gave, but also a bit of a chain of thought reasoning. We said, okay, follow these steps in your reasoning. Of course, the balance there is the more reasoning you do, the slower the response. And already right now, it was kind of at the edge of what's acceptable. But yeah, lots of prompting strategies to try there.
May I ask a personal question following up on Roger's question? When you say at the edge of what's acceptable, who defines what's acceptable?
Yeah, that's very difficult to define, right? I know there's one paper from KTH where the maximum acceptable delay in spoken conversational system is placed at about 1 second. So that's already very fast. I
It
wasn't
is.
able to meet that in this system, but yeah, it's very subjective, of course,
It is.
what actually is acceptable if you're pushing the state of the art of it.
You're right. And for our last question for today, we have a question saying, "Hi, thanks for the interesting talk. And what do you think about speech-to-speech model?"
Yeah, super interesting. I haven't played around with them as much as I wanted. There, it seems very possible to go beyond that speed problem, of course, that we were just talking about, because you're generating the audio, the speech directly as a response to the speech. But then the problem is, how can we control what happens in between with large language models? If you combine them with speech to text and text to speech, there you've got quite a bit of control because you are prompting the system. You can split up the prompt in different things. You can combine them with other systems such as a retrieval augmented generation system. With speech to speech model, I don't quite see that yet, but maybe you know more, the person that asked this question or somebody present here knows more about how to use these systems, and then I'd love to get in touch. But I think it's very promising, but I don't yet quite see how to integrate them with the level of control that we want to have in our studies.
That makes sense. That makes sense. I love it that since you don't have that much like insights in that part, you're saying very humbly that maybe someone else could could have more knowledge about it. Very interesting talk, and we had a lot of questions here. So thank you again so much, Ruben, for joining us today and for sharing your work with us.
Thank you very much. Very happy to be here.
Thank you.